Good morning. Today we are starting chapter 8. It says apply exponent properties involving products. So today we're going to focus on products, which means we are multiplying. However, I'm going to go back to our learning target for a second. It says I can apply the properties of exponents to simplify. We are not solving. We are not plugging things in our calculator. We are just simplifying. So if you give me a big, long answer that you plug this in your calculator, I'm going to tell you that's wrong because we're simplifying, we're not solving. 7 to the power of 3, or 7 with an exponent of 3, means that this is really 7 3 times. So I'm going to make this a little chart here, and we're multiplying that by 7 5 times. 1, 2, 3, 4, 5. Oh, that was 6. Only 5. So here is 7 3 times, multiplied by 7 5 times. Well, how many 7s are there? We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 7 multiplied 8 times. So it's really 7 times 7 times 7 times 7. Okay? So all we're doing is simplifying. 7 3 times multiplied by 7 5 times would be 7 8 times. Now some of you might be thinking, well, 3 plus 5 is 8. And that's correct. However, we need to write it out the long way to first show our work, but second, later on, we're going to get to some more complex problems that aren't going to be as simple. So let's take a look at this next one. We have 3 terms here. This is really 9 to the power of 1. We normally don't write that because we know it's just 9. But then this is 9 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And this is 9 2 times. So total, we have 8, 9, 10, 11 9s. So 9 multiplied 11 times. So that's our answer. We simplified. Down here, these are touching, so I know that's multiplied. Again, just like this 9 to the power of 1, this is really negative 5 to the power of 1. We just write it one time. Over here we have negative 5 6 times. So there's negative 5 6 times another negative 5 would give us negative 5 7 times. The reason why I put this in parentheses is because negative 5 to the power of 7 might give you a different answer in your calculator than with the parentheses. It will depend more if we have an even exponent instead of an odd exponent. But make sure that's multiplied in parentheses because it's really negative 5 times negative 5. If you just put negative 5 to the power of 7, that would be negative, and then we have 5 times 5 times 5 times 5. They forgot to multiply the negative each time. So that's why it is in parentheses. Same thing here, we just have a letter instead of a number. This is x 4 times, 1, 2, 3, 4, x times x times x times x. And this is x 3 times. So total we have x 7 times. 4 here plus 3 more. So that's our answer. Now we have what's called the power of a power, which meaning we have 2 to the power of 5 also to the power of 3. Well, look at your outside exponent first. Just like back here, the outside exponent told us how many times to write it. We wrote this 3 times. We wrote this x 4 times. So now we're going to write whatever's in parentheses 3 times. 2 to the 5th, 2 to the 5th, 2 to the 5th. I wrote that 3 times. So now we have to just simplify. Just like the last problem now, each of these 2 to the 5th is really a 2 5 times. There's a 2, there's a 2 5 times, and there's a 2 5 times. So simplifying this, how many 2's do we really have? We have 5 plus 5 more plus 5 more is 15 2's. It's a 2 multiplied 15 times. Now some of you might make the connection that, hey, 5 times 3 is 15, and that is correct. However, like I said, we'll get to some more complex problems later where you're going to want to know how to write it out. Alright, look at your outside exponent. First, we're going to write whatever's inside our parentheses 5 times. So we have negative 6 squared 5 times. Negative 6 squared, to the power of 2, negative 6 to the power of 2, negative 6 to the power of 2. Oops, that was wrong. Negative 6 to the power of 2. It's 4 times, one more. There, I wrote that 5 times. Now I need to simplify this. I know that each of these 6's is really a negative 6 2 times. Negative 6 2 times. So total, I have a negative 6. How many times? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. So my answer is negative 6 to the power of 10. Now again, you could multiply these, but some people get confused with all the parentheses. And remember, this would be incorrect. Okay, you need to have the parentheses on the negative 6, because this was really negative 1 times 6 to the power of 10, where this is negative 6 times negative 6 times negative 6, over and over and over again. Let's move down to the third one. We're going to write whatever is in parentheses on the outside 4 times. We have x squared, x squared, x squared, x squared. So hopefully you know each of these x's. This is x squared, or x times x. This is x times x, x times x. So total we have 2, 4, 6, 8 x's. X to the power of 8. Or you might know 2 times 4 is 8. But I'm showing my work. This is where it gets important. That's why I have a star in this one. I need to write this whole thing 2 times. So in parentheses I have y plus 2 to the power of 6. I'm going to write that 2 times. I always put the multiplication between here because it's squared. It's multiplied by itself. Y plus 2 to the power of 6. Now, some of you might know each of these is going to be y plus 2. 6 times. Now, that's going to be a lot of work, so I'm going to stop. And I know that there are going to be y plus 2 how many times? Well, there's 6 here and 6 more, so it would be to the power of 12. We cannot simplify this anymore because there's a plus in the middle there. If it was a multiplication, then we could simplify, but whenever you have addition or subtraction there, you can't simplify that any further. Okay? You could not do y to the 12th plus 2 to the 12th. We are just going to leave it as y plus 2 to the power of 12. If you have questions about that one, let me know. This is where we get to multiply separately. Because back here, like I said, this one had a plus sign in between here. We would have to multiply y plus 2 times y plus 2 in order to simplify that 12 times. And that's not going to give us some very nice answers. But if we have a multiplication sign between here, we can multiply. This is really, not 12, 24 times 13, 8 times. 24 times 13. And because this is all multiplication and this is multiplication, it doesn't matter what order you do the multiplication in. So I know there's a 24 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And I know there's a 13 8 times. So overall, I know there's going to be a 24 multiplied 8 times, and it's multiplied by a 13 8 times. So the only reason I was able to do the 8 on both of these is because of the multiplication. It doesn't matter what order you multiply in, but I know there's 8 24s and 8 13s. Now in this one, this is why it's important to write out what we have. We're going to write everything that's in parentheses 2 times. 9xy times 9xy. Now, the 9 and the x are touching, that's multiplied. The x and the y are touching. So these are all just multiplied. So some of you may be thinking, well, how many 9s are there? If you wanted to write it out like this, you could, but there's only one 9, one x, and one y, so it's kind of silly to do that. So we really have a 9 2 times, so 9 times 9 would be 9 squared. And then we have an x 2 times. X times x would be x squared. And then we have a y. Oops, this is a y 2 times. Y times y would be y squared. So this would be our answer. However, if it's a small exponent like 2, sometimes I might actually multiply that out. Like 9 times 9 is 81, and then x squared, y squared. So look to see, I would accept either of these, but just so you know, if it's a small exponent, I would say 3 or less. Most of the time they multiply that. So this is where the mistake comes in, because some people just might put y squared, but it's really, because it's multiplied, everything gets the 2. Just like here, everything got the 8. Every number, when they're multiplied, gets the exponent of 2. Alright, let's take a look at this next one. We have negative 4z 2 times. So negative 4z times negative 4z. We had that 2 times, so I wrote it 2 times because of the square. So this is really multiplied here because they're touching. So these are all multiplied. It doesn't matter what order I multiply in. I have a negative 4 2 times. So negative 4 times negative 4 would be right here. And then I have z 2 times. Z is z squared. So as you can see, the negative 4 got the squared and the z got the squared. Now the reason why the negative 4 is in parentheses is because it's a negative 4 times a negative 4, which would really make a positive 16 when you multiply it. So this one will give you 16z squared for our final answer, or you could leave it like this. However, it's a small exponent, so you could multiply it out. And then here, this is the same question, but the negative's on the outside. So let's see the difference here. This one, we're only going to write what's in parentheses 2 times. 4z times 4z. This negative is really a negative 1 out front. So we really have negative 1 times, and then we have 4, this is multiplied really, times 4. Well, that's 2 4s, so 4 squared. And then we have z 2 times, so z times z is z squared. So now if you multiply this out, 4 squared, or 4 times 4 is 16, but it's also times a negative 1, which is just negative 16. So we get the same answer, except one's positive and one's negative, depending on where our negative was to begin with. So now let's use all of the properties that we have learned. I'm going to start by looking at this in 2 different sections. Just this part first, I'm going to write it 2 times. 2x to the third, 2x to the third. I wrote that 2 times, and over here I have x to the 4th. Well, I know this is just a 2, and this is x 3 times. This is just a 2, and this is x 3 times, same thing. And this is just x 4 times. So if we simplify this, well, there's 2 2's, 2 to the power of 2, 2 times. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. X multiplied by itself 10 times, x times x times x. So this would be an acceptable answer, but since this is so small, 2 times 2, or 2 times is 4. 4x to the 10th. Let's do the same thing over here on this one. This is just a 5. And then we have times this whole piece 4 times. 5x squared, 5x squared, 5x squared, 5x squared. So I'm going to multiply all this out, or show some work here. Each of these is just a 5, and then this is x squared, so 2 x's. This is a 5 and 2 x's, a 5 and 2 x's. So a total, how many 5s do I have? 1, 2, 3, 4, 5 5s. 5 to the power of 5. And then there's 2, 4, 6, 8 x's. 5 to the power of 5 would be a really big number. If you wanted to plug it in your calculator, you could, but since it's such a large exponent, normally you just leave that and simplify instead of solve. So this would be an appropriate answer. And this is why we show our work, because here, 5 to the 4th, that got you this one, but then there's one more here. That got you 5 to the 5th. And then here, some of you might want to add and say there's 6 x's, and that's where people make mistakes. There's really 8, because they're touching, we would multiply. So here's another example of that. We would write 9m to the 3rd times n 4 times. 9m to the 3rd n, 9m to the 3rd n, times 9m to the 3rd n. One more, 9m to the 3rd n. So I'm going to multiply or show my work here for each of these. This is 9. This is m to the 3rd, 1, 2, 3. But this is just n. There's only one n here. Same thing here, 9m 3 times, and then just one n. 9m 3 times, and one n. 9m 3 times, and one n. So first, let's count up our 9s. We have 1, 2, 3, 4 9s, so 9 times 9 times 9 times 9, or 9 to the power of 4. Then we have our m's. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, m to the power of 12. And then last, our n's. We only have 1, 2, 3, 4 n's, so n to the power of 4. And that would be something that could potentially be seen here, but a lot of times people make mistakes. That's why I'm showing our work. Now, here's a tricky one. This is negative 20x to the 3rd 2 times, so I'm going to write that out 2 times, multiplied by negative x to the 7th. So I'm going to write this out first. Negative 20x to the 3rd times negative 20x to the 3rd times negative x to the 7th. I wrote that out 2 times, and then with the extra piece there. So if I multiply or show my work here, this is a negative 20 and then x 3 times. This is a negative 20 x 3 times. And then this is negative x to the power of 7. This isn't a negative x 7 times. It's a negative 1, and then we have 7 x's. 1, 2, 3, 4, 5, 6, 7. The parentheses are not on the inside here. They're on the outside of the 7. So we don't multiply the negative 7 times. So, oops, what happened here? To simplify, we have a negative 20 2 times. We also have this negative 1 that's multiplied. I'm just going to put that negative 1 out front. And then we have x, how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So some of you might want to simplify this because this is pretty ugly here in the front. A negative 20 2 times, negative 20 times negative 20 would make a positive. 20 times 20 is 400. But then it's also multiplied by negative 1, which means now that 400 is just now a negative 400, x to the 13th. So let's move on to the next page. Now it just says find the missing exponent. So if we write this out like we've been, we need to get to a total of 5 x's. And here we have 4 x's. So here we're missing how many? Well, 4 to get to 5. Oops, I only did 4 here. To get to 5, we only need 1 more. So we would need 1 more x here, so that question mark would equal a 1. We missed 1. Here, we need to get to a total of 16 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 y's. Right now, we only have 8 y's. 1, 2, 3, 4, 5, 6, 7, 8. But this exponent, this parentheses here, tells us that this is a group. So how many groups of 8 do we need to get to 16? Well, we would need 2 groups. So we need to multiply this or write this out 2 times. So we would need 1 more. So for a total of 2. So that question mark would have to equal a 2 because we need 2 groups of 8 in order to get to this 16. Down here a little bit trickier, so I'm going to write everything out. We need to get to a total of 18a to the power of 9. So first, I'm going to write out what we have here. I know I have a 2 and a 3 times. And then in here I have a group of 3 and then a to the third. So I need to figure out how many groups of this do I need to get to a total of 18 and then a to the 9th. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 3 are already taken care of. So we need a total of 6 A's. Right now we have 3 over here. And we need to get to 18. Well, 3 times 2 is 6. We'd have to multiply again. 6 times 3 would be 18. So we need 1 more 3 over here, and we need 3 more A's. So how many groups of this do we need? Well, we need 2 full groups. So that question mark would have to be a 2. What I'm doing is I'm just looking at what do I have in the end. I'm going to simplify, like what do I already know I've taken care of, and then what do I have left. So if we look at this next one, I know I need 8, and then z to the power of 15. Well, they're telling me here my groups are going to be 3 groups. So I'm going to have 3 groups of numbers and letters. Each one is going to have a 2 in it, and then each one is also going to have some z's in it. But I don't know how many z's. This is what I need to figure out. How many z's go in each to get to my total? Well, I know that I have to have 15 z's in all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 z's total. So I kind of set it up nicely here because I know there's going to have to be 3 groups. So each group, there would have to be 5 z's. So that question mark right there, if we have a 5, so there's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. That will take care of all the z's, and then 2 times 2 is 4, times 2 is 8. So that question mark would have to be a 5. There are 5 z's in each group. There are 3 groups total. Alright, a couple more. It says the metric system has names for very large weights. 1 giganton is 10 to the 2nd power times the weight of a hectaton. 1 hectaton is 10 to the power of 2 tons. Write 1 gigaton in tons. So it says we need to write a gigaton. So a gigaton is 10 to the 2 times the weight of a hectaton, and a hectaton is 10 to the power of 2 as well. So if we simplify that, well, how many tens would there be? This is 2 tens, and this is 2 tens. So total would be 10 to the power of 4. If you wanted to, you could multiply that out, but we would accept it in exponential form. So then part B, 1 teraton is 10 to the 9th times the weight of a kiloton. Well, a kiloton is 10 to the 3rd tons. Write a teraton in tons. So a teraton is 10 to the power of 9 times, meaning multiply, the weight of a kiloton, which is 10 to the 3rd. So let's simplify that. I know this is going to be 9 tens. This is 3 tens. So how many tens would there be total? 9 plus 3 more would give us 12. So finally, 1 exacton is 10 to the 6th times the weight of a teraton. Use your answer from part B to write 1 exacton in tons. So it says 10 to the power of 6 times the weight of a teraton. Well, we figured out that right here, 10 to the power of 12 is a teraton. So let's simplify this. This would be 12 tens if I wrote that out 12 times. And this would be 6 tens. So total 12 plus 6 more give us 18 tenths. So finally, this is just a review. Properties of exponent. If we have the same base, or a times a, we learned that we can just simply add our exponents. Product of powers, that's what that's called. But if they're touching, everything gets written out that many times, or we're really multiplying those exponents. It's called a power of a power, meaning there's two exponents. You're multiplying those. And then power of a product property is, product means we're multiplying here. Everything got the exponent of m. So those are the properties that we actually learned today. You don't need to know the names for them necessarily. If you want to, you can. But you just need to know that, hey, if I have, for example here, x to the power of 4 and x to the power of 3, well, you really just added those exponents because this is 4 x's and this is only 3. You added 4 plus 3 to get 7. That's really what you did here. If you have more questions about those, please let me know. Otherwise, your homework is a worksheet. Do not write your answer as a number, just simplify. Alright, down here you can simplify the first number, but leave everything else as an exponent. On the back, you can cross off number 28. Otherwise, good luck. We did this one together as well.